Begin.
Quiet down. Here we go. Exercise 14G now. So, we had an expectation, or I had an expectation that you learned your exact values, okay, and I then taught you symmetry properties for 14F. So things like sine of pi on 6, cos of 11 pi on 6. If I said tan of negative 2 pi, you're able to do that. And I am going to test that at the end of this session. Before you go, you have to answer one. You get it correct, you go. You get it incorrect, you keep staying back until you get it correct. Okay? So, you have to know your exact values, you have to know your symmetry properties. And now today's lesson, I'm now going to introduce the idea of the graph for each function. You have sine and cosine function. I can get it in depth with it and make it difficult, or I can just give you the simple how to sketch for now. Okay? So I'm going to give you the simple and how to sketch for now, and as we move forward, then I'll start explaining why it works. So you're going to just memorize. So no questioning. You just believe that what I say is correct, and you don't question it. Okay? You're just going to believe in it. So here we go. How do you do 14G? Just to start off with, these are your formulas to copy. Okay? Now, I know it looks weird there, so I just want you to copy what I'm going to box out here. I want you to copy this. And I want you to know that A is called the amplitude. Okay? So what do I want in your exercise books right now? What I want you to copy down is 1. To find the period, it will be 2 pi divided by n. 2, what I want you to copy down, A times sine of nt, and another one is y equals A times cos of nt, where A is the amplitude. And I will describe what an amplitude is and what n is. I'll do some examples, and then once it looks good and I do the testing of symmetry properties, then next lesson on the Monday I will describe why they work. Okay? Because it all goes back to chapter 7. Transformations, dilations, dilation of factor data from x-axis or y-axis. Then it makes a lot of sense why this is the correct formula, 2 pi divided by n. It all comes from your transformations. Okay? But for now, just for the sake of doing exercise 14G, you're just going to blindly follow what I tell you. This is the period formula, and this is your function without moving left, right, or up and down. There's no up, down, there's no left, right at the moment. There's only A and N. If you don't like the letter T, you use X if you want. So X and Y, X and Y. It's just traditionally in your textbook they use T. Okay? If you prefer X, we can use X. It doesn't have to be T. Okay? All right. Now, let's have a look at a graph. Okay, I'm going to just give you the graph. You're going to memorize it. So here we go. This is from a domain of 0 to 2 pi. This is the graph of your sine graph. Okay, so when you write y equals to sine of x, okay, this is what sine looks like. This is what a sine graph looks like. So the question is, what's the period? What is the amplitude, right? If we compare this y to sine of x to the sine of x I have over here, what is a equal to and what is n equal to at this moment? What is A equal to, Trent, looking at my diagram at the moment?
1.
1. See, the value in front of sine right now is 1. So I know A equals 1. And then N, what would N equal to in this case here, Finn? What's N equal to? 1. Okay? Now, since N equals 1, apparently the formula I gave you, I told you to copy that down, period, is equal to 2 pi divided by n, which is 1. That gives you 2 pi. So the question is, what is the period? Period just simply means, because a sine graph, it's actually going around a circle, right? When doing a unit circle, you can do infinite revolutions. That means when you sketch it, you can do infinite oscillations. Okay? So, this is where we started. We started at 0. You see, I went all the way to the maximum of 1. I came all the way down to the minimum of -1, and then I end up at 2 pi. Now, if I continue the graph again, that's my second cycle, where I'm moving up again. I reach 1, come back down, reach the -1, and then back to 0. This is called one cycle. One cycle is period. Period is how long does it take to make one cycle. That's what it means. Okay, so if I draw a graph right now, if I did another sine graph, if I did this, and it keeps going, right? Then the question is, how long does it take? So if this is 1 up here, how long does it take before I reach 1 again? That's called the period. The period is the length of time that it takes to get back to the same spot again. Okay? In this case here, I just happen to choose the spot that I wanted, which I'll do in red. The spot that I wanted was here, and I ended up here, right? But I could have easily chosen this spot here to reach that spot there. I could have said, from here to here, how long does it take, on the x-axis, how long does it take to get there? That's called your period. Okay? So, the period just tells you how long the length it is to make one cycle. And the cycle could start anywhere. It could have started here. How long does it take to get back to that 0 point again? That's what the period means. So when I look at this and I say 2 pi, it just means that when I go up and all the way down and back to the same spot again, it takes a distance of 2 pi. That's why the endpoint I've labeled 2 pi. Because that's how long it takes from 0 to this spot. That's how long it takes to finish one cycle. That's period. Okay, so if I do another one, do another cycle, then I add another 2 pi. It goes from 2 pi to 4 pi. Okay, and if I do another cycle, then it's 4 pi to 6 pi. Okay? Now, that's what period means. Then what's the amplitude? Amplitude, when you say 1, it actually just tells you the maximum and minimum height. That's what it tells you. So if you say 1, that's what it's saying. It's just saying from the center of the graph, there's a maximum and there's a minimum. So the center up is 1 unit. Center down is 1 unit. It doesn't matter if that's a -1. If it's a -1, it just means it's a reflection. So the shape of the graph changes, but the unit, the length of it is still 1. That's what amplitude means. Okay, so amplitude is always a positive number. It's not a negative number. Okay, so even if I gave you this graph, hypothetically, if I gave you y equals to -2 cos of x, amplitude is not -2. A lot of students write that in the exam. They think, oh yeah, a is the number in front of cos, and they see -2, and they put -2 as a. Not true. See, amplitude is the value, it's the distance. Distance from the center, and the value is 2. The negative just tells you the shape. It's a reflection. So it just means it's upside down. So instead of going up, it goes down. Okay, for a sine graph. In this case, I haven't changed it for a cos graph. Okay, so the negative is a reflection. It just changes the shape of the graph, but it doesn't change the length of the height and the minimum. Okay? How do we feel so far? Does that make sense? So I just got you to memorize the period formula, and I got you to know that the value times into sine or cos tells you the amplitude, how high it goes up and down. Okay, now I'm going to do an example, and we're going to go back and then we'll do cos. Okay, so let's do an example. Here we go. Let's do this one. Let's do B, because I just showed you sine. Let's do B. Okay, so let's look at B. I've got y equals to half multiplied to sine of x over 2. Now in this particular case, what is my A value? 1.5. A equals half. So A equals half. What does that mean? It just means that when I draw my sine graph, which looks like this is my sine graph. Okay, that's my sine graph. I'm doing just one cycle. Now I can continue on, but let's just do one cycle. The maximum and the minimum has to be positive half, negative half. Okay, so the minimum here is got a length of half here and a length of half there. But the coordinates, we would then say maximum value up here is half, and this bottom here is negative half. Okay, that's what A does. So A tells you the amplitude. If you really think about what I told you in chapter 7, that's just a dilation. It just means you're shrinking the graph from the x-axis. You're shrinking it by half. That's why it went from 1 and it shrunk down to negative half and half. That's all. Okay? Anyways, let's look at the period now. I gave you a formula for the period. Period was equal to 2 pi divided by n. Now, what's my n in this particular case? A half. Okay, a lot of kids will think it's 2 in the exam. I'm talking about year 12 students, and this is the common one that comes up in the exam. Examiners normally put fractions because they know fractions get students, right? This is actually 2 pi not divided by 2. That's a half there. That's another way of saying half times x. So n is half. So really, you got 2 pi divided by half. That's what it is. You actually have 2 pi divided by half. And what's 2 pi divided by half? 4 pi. And that's where a lot of the students might find that difficult, okay? Just fraction on fraction. So 2 pi divided by half. In case you didn't know your fractions, it's times the reciprocal. That's why it end up being 4 pi. So what does it mean for 4 pi? It just means that if I drew my sine graph, it takes a length, or how long does it take to make one cycle? It takes 4 pi. Okay? Now the cool thing here is, if you know this is 4 pi, which is the length from here to here, this is all symmetrical. Remember, in unit circle, everything's symmetrical. Yeah, the top half, bottom half. Now it's the same thing. If this is 4 pi from here to here, then what would it be from here to here? 2 pi, because you're halving the length. Okay, so halving it will give you 2 pi. And then if I asked you, this is the center, which is the quarter of a circle, to get to this maximum point, then what's the middle of 0 and 2 pi? Pi. So at pi, I would have the maximum value. We would write here pi, and then this middle here would then have to be 3 pi. And what I've just done is sketched 14G, one complete cycle of this graph here. So you need an amplitude, the length, and I've just labeled the key features. Okay? And I'm going to then explain, after you get a bit of practice of this, I'll then explain why it's every quarter. Because in your circle, it's every quarter. Yeah? We always do 90 degrees, 90 degrees, 90 degrees, 90 degrees. That's essentially what you're doing here. You're doing 0 to 90, and then 90, and then onwards. Because you've got a dilation of factor 2 from the y-axis. That's why it's stretched out. Okay? How's that feel so far? Does that feel a bit more, it makes a bit more sense? So I'm just getting you to memorize things right now. Just period, amplitude. That's what I'm getting you to do. Period, amplitude. Sketch the graph. Okay? Now the only thing we're missing right now is what a cos graph looks like. So you know what a sine looks like? Sine started at 0 and it ends off at 0, right? Starts off at 0, goes all the way to the top, goes all the way to the bottom, comes back to 0, right? Cos graph looks like this. Now I want you to copy this one down. This is what a cos graph looks like. Cos graph, on the other hand, starts at the maximum, goes all the way down to the minimum, and comes back up back to the maximum.
Because since it's cos, you're effectively starting halfway through the pi. It's why it starts.
Okay.
That makes sense.
So this is your shape. So instead of like a sine before started at 0, and then it reached to maximum of 1 in the previous graph, and it comes back to down to 0, negative 1, and back to 0. This is the normal cos graph. So the cos of x, amplitude is 1, that's why maximum height is 1, minimum height is negative 1. Yeah, so still 1 and 1. That's what the amplitude is. Period is still 2 pi on n, which is still 2 pi. That's why the length, starting at 1, I end back at 1. How long does it take to make that one cycle? 2 pi distance. That's what the period is. In between it, I've just labeled the graphs here. So I've got 2 pi, 3 pi and 2, pi, pi and 2. And what you should feel is this is very similar to the unit circle. So unit circle, you start at 0 degrees, went to 90 degrees, to 180, to 270, and then finally 360. Okay, and this is all the exact values if you really think about it. If I asked you what is cos of 0, you'd say 1. If I said what's cos of pi and 2, you'd say 0. When you say what's cos of pi, you'd say -1. And that's what I'm doing. I'm just sketching the cos graph, the cos values. Okay? So just in case you're still trying to get your head around the cos and sine graphs, I'm going to draw an equivalent one, and you can do the comparisons between the two. Okay? So here we go. That's the, oops. Oh. I know. Which I can't do it on the screen. All right, here we go. This is your sine graph. So I'll draw it again. Sine starts at 0, goes up, comes back down, comes back to the center. 2 pi, pi, pi and 2, 3 pi and 2. Maximum 1, minimum -1. So 14G, you're just getting used to the idea of period, amplitude. Period, the amplitude. Okay, that's what you need to understand. That's 14G. So 14G, they'll give you questions like these two, and your job is to find out what is the period, what is the amplitude, and then sketch accordingly for one cycle. Okay, so they'll say show one complete cycle. What makes it harder later on as you do H, I, J is that they'll move the graph left, right, up, down. That's when it gets tricky. Because you're going to have to find the x-axis intercepts, and remember, you have to know E and F to find x-axis intercepts. But graphing it, you've got a better idea now. Okay? The only thing you're missing is the y parts. Okay? But at the moment, I'm just teaching you how to do it. So that's how you do it. Okay? So let's try this one now. I want you in your exercise, we'll have a go at cos of 2 cos of 2 theta, or 2x. Think of theta as x. Okay? I want you to roughly sketch this on your own axes, and then I'll do it to see if you've done it correctly. So I want the amplitude to be correct, I want the period to be correct, and I want all the inner, like the quarter cycles to be correct as well. Okay, so I want you to do A. Let's do A. If you can do A, then that's 14G there. That'll be 14G. And then I'll put up the slide so you can have a look at the problems.
T is short x. Replace T of x. Yes, that's the fact. Number.
I usually draw the graph and then label. I draw the graph and then I label it.
I'm putting it in a student slide. Now it would be handy to have graph paper. Didn't really matter with like hyperbolas or parabolas or whatever. It'd be nice to be able to have like the same amplitude. So like being on graph paper. Make sure that you get the same line.
All right, let's have a look at our answers. What's my amplitude in A? What's the amplitude equal to? Can I please have Hamish? What's the amplitude in the first one? 2. 2 is correct. A is 2. Amplitude's 2, so that means maximum is 2, minimum is -2. I've got a cos graph, so I'm going to draw a cos graph. This is what a cos graph looks like. So hopefully you drew something that looks like that. Okay, so your maximum, minimum. The only thing you're missing now is the period and then the x-axis intercepts of the quarter cycles. Okay? Now, what is the period equal to? Can I please have Olympia? What's the period equal to? For the first one. A. Oh, sorry. Okay, let's do Charlotte. Were you doing this question? No? Anna? No? Seb? What's the period?
Pi.
Pi is correct because n is 2, so 2 pi on n, which is 2, that gives you pi. So what that means is, from one cycle, to make one cycle, it takes pi distance.
2 times theta.
Okay? I know that the center has to be then half of pi, and then this would then be
Not 20.
half of pi and 2.
It's 2 feet if it's not 20. It's a straight line through the middle, not a diagonal line.
There we go. You can see, I know the period was pi. Halving it's pi and 2. Halving it again gives you the quarter cycle, pi and 4. That's what I just needed to do for 14G, just getting familiar with the graphs. Later on, I want you to relate back to the unit circle. So everything comes from a unit circle. So the better you can visualize a unit circle, the better for you. But at the moment, you're just going to memorize this as it is. This is the cos graph, that's the sine graph. A is the amplitude, and it will affect the period. Okay, so I haven't described why it all works, you're just going to follow as it is. How's that feel? Good? Excellent. Here we go, 14G. These are the questions. And then I'm just going to call you up. Show me your homework. Oh yeah, sure.
Wait, damn, I had something to say.
Where's my 14G?
You don't pay attention. If you're playing with, you don't know how to do it.
I'm loving that. You know what? You guys can put like a rap to it.
No.
It'd be the chorus part. It'll like pause.
Nah, it's gone.
Mr. Chan, you will.
Did I ruin it? Did I ruin it?
You're cool, but yeah. Come from the 4 notes sitting in the front, but still.
Oh my god, I left when I thought you finished teaching.
I never finished teaching.
Take too long.
Why? Why, Seb? Why do I never finish teaching? Go, give that line again.
It's like trying to teach you something. You don't pay attention and complain that you don't know how to do it.
You had the whole, yeah, you lost it. You guys are now shy.
Bigger.
All right.
This is year 11.
This is year 11. This is 14G. Those are the questions up there. Have a look. I'm going to mark.
Okay.
What are you doing here?
Me? Oh, I met up with some of my friends because they wanted stuff.
Why are you wearing a uni high top?
Oh, because I went to a gym.
Oh, that's awesome.
I know.
That's awesome. You can blend in as my students here.
I know.
That's
No
cool.
one
No one
there's-
knows. No one
yeah.
questions it. Look, they welcome you. This is Venue, everyone.
On the back.
She graduated last year. Never taught her. Actually, no, I did. Year 9?
did?
Once.
He forgot.
Forgot her name.
I need to explain to you how this works. So this is question 1, and then question 2, question 3.
Oh my god.
And then just some other stuff.
Okay.
And then that's question 2.
My god.
Actually, no, you should probably start with it's messy.
You're telling me what to do.
The most rude.
I don't like being told what to do.
I'm just nervous. So you don't, well, maybe I can help. So you don't get.
Can you?
Guess what? I got a high distinction for my stats last semester.
Oh my god, that's awesome.
Proud of me?
I am.
You should
I've
be.
forgotten all my stats, which is more useful than anything else.
It's not. It's gross. It's disgusting.
That's awesome, stats.
I know. I got high distinction. Now I'm doing Oh wait, it was stats computing.
Yeah.
Now I'm doing stats. I'm still at the HD level. It's good.
That is really good.
I know.
How's Murray doing?
He's great. Something bad happened to him recently.
That sounds really bad.
I know.
Should I know?
Yeah, you should.
I should know.
Yeah.
Am I meant to feel bad? What if I don't cry?
No, you don't need to cry.
Okay. Okay.
You feel
What? Oh.
I know, it's so, but it wasn't his fault though.
What do you mean? You're like, how do you not?
Because because he was trying to turn to the intersection, the main road.
Yeah.
So he was turning right? So there was a safe gap. But when he turned, this truck driver got kind of annoyed. So he sped up all the way to the back of his car and started honking it.
Oh.
You know what I mean?
Oh.
So his temper made him get worried. Then the test driver was like, "You made someone mad, so you feel."
Ah.
Which is stupid, right?
Well, it depends on how he was driving.
think it
but
was stupid.
yes, yeah. That's unfortunate.
And my mom is someone who's like very honest, right? But
Yeah.
she was like, "There's no way he failed," because she thought I was lying.
Yeah. Reason why you've got everything correct is just that in the so 360 degrees is all the way here. Then you minus 45 degrees, right?
It's going to be negative.
Yeah, so because it's in the bottom region, so it's negative 1, right? So it's negative there. Which I should put red, otherwise you think I've done it.
You've been doing your
So far so good, and that one we don't write pi. If you're going to write pi, then you have to write that as pi and 6. Yep. But so far so good, Lauren.
And there's also,
What's the other one?
you don't have to look through this. It's just like the rest of 14.
No, I want to look at this one. This is the one that is key.
Very hardworking.
Sorry?
Why?
Yes, you may.
It makes us stay back if we don't do it, so.
Trust me, yeah. Fair enough.
She makes me stay back. Or every time. Every time.
I'm guilty.
I didn't even teach her. She was just like,
Did you?
I need your help.
Yeah, I made him stay back to 7 actually. It's fine. When you're in year 12.
Feel my pain.
When you're in year 12.
When I care too much about you guys, okay? I've learned to let go.
Oh yeah, you guys are unlucky though. It became like what? What are you now?
Is this mine? Oh, this is all my stuff.
This is negative.
Oh, sorry.
So you got to correct again. You've
You can
drawn
look at the units. Okay.
Yeah, unit second.
You know
So
what's
it's down here.
shocking? I
So you're doing really well. It's really well.
That's
You're breaking it all
sad.
right though. It's so good. Your fraction, because I remember I taught you in year 8 fraction. You and
Eve.
yeah, this is really good.
Do you have a sister that graduated last year?
Maddie Sorich.
Ah, okay,
Yeah.
that explains why you look so.
Did you not know that was
familiar.
my sister?
No,
Oh,
You didn't know she was my
So
sister?
much like Maddie.
she does.
You see what I mean by
Madeline Sorich.
But is it Sorich?
dear Lord?
Yeah. Oh wait, do you think that it's like C with like an accent?
No, I thought her surname was Sergeant or something like that.
Oh
no,
no.
that's a different
There's
one.
another
Yeah.
There's a Maddie Sargent as well.
Oh.
There's two.
That's 3. That's
Yeah, she
one
doesn't
of
look
2.
like Maddie.
I don't look like Maddie Sargent. No.
No,
Don't
you
you?
actually do. You
She
actually
does.
do. You do look like
She
Maddie
does look
Sargent.
similar to Maddie.
I
Sargent.
thought you were like Maddie Sargent's sister,
Oh.
but I
Maddie
knew
Sargent.
like yeah.
No, I don't know who she is then.
They both kind of look alike.
I don't remember what Maddie said.
How is she?
She's good.
Yeah.
She's having a good time. Yeah.
Good time?
Yeah.
That's good.
Yeah.
Is she in uni?
Yeah. She's at Melbourne.
What just happened?
Oh, okay. What's she doing?
Oh, okay.
She's doing arts, but she's majoring in psychology.
Hey, it's like
Yeah.
me.
Yeah.
Like me.
Oh really?
Yeah.
You will remember.
I forgot how
Yeah,
boring his class is.
That's right. You were never in my class, so you can't make that
I
statement.
went to your class before.
Did you?
Yes!
don't remember
You
you
had 12? I was always in your class.
Don't ruin my page.
Why keep coming to my class? Go to your own class.
I don't have. Oh, yeah, but you can't ask me to go back to my
Like
class.
that. This way
Back
is
then.
really superior. Anyone else who doesn't
No,
know
you
the
can
way.
find them.
How? Are you
So
married?
you get a circular arrow.
What's her name?
Not yet.
What's her name?
Stacey, you forgot
Yeah,
Stacey
how's
already.
Stacey?
I remembered Murray and you don't remember
Yeah, but
Stacey.
Mari was your student.
Go away. I don't even want to talk to you anymore.
How's Stacey? How's
All
her
those hard
How's
work.
her
Did
parents?
Ven